Hello, this is 11172 Static Discharge, and during our autonomous period, our main objectives are to detect the custom signal sleeve using the camera, accurately navigate and park using our odometry system, deposit preloaded cones at any of the junctions, and grab and deposit the cones from the stack. So our key algorithms in order to do this include the holonomic odometry localization, which means that we constantly know the position and the orientation of the robot on the field. And in order to do this, we use a third-party FTC-lib localization algorithm, and then we also have the option of using a custom localization algorithm, which we derived from complex plane integrative calculus and a system of equations. We also use vector interpolation path following to use the odometry localization in order to reach the desired position on the field. In addition, using our linear slide for encoders, we can also reach the desired height of the linear slide using the encoder system, which can also be used during the teleop for driver assistance. Another key algorithm is the Euphoria and TensorFlow combination we use. So we use the Euphoria in order to format the camera input for the vision model that the camera can see. And we use a custom trained TensorFlow model which reads a custom signal sleeve that we created. In order to make a robot as precise and consistent as possible, we use the holonomic deadwheel odometry, which constantly localizes the robot using the encoder input from the dead wheels. And this allows us to accurately navigate during the autonomous period. And we reorient the controller input to a global space in order to make driving more intuitive during the teleop period. We also use a color sensor as a backup to the odometry to align with the cone stack using the range sensor part of the color sensor, and also aid the driver during teleop and endgame in grabbing the cones from the cone stack or depositing it to the junction by rumbling the controller when a cone is detected in the claw. And we also use the camera vision sensor in order to detect the custom signal sleeve for optimizing our autonomous parking. In addition to rumbling the controllers when the cone is in grabbing range using the color range sensor, we also give the drivers an option to use gyro compensate in order to drive the robot more intuitively. We also use the controller buttons to immediately go to the depositing height for the linear slide for any of the junctions, and also use the controller buttons to toggle between the fast and the slower speeds for quick or precise movement.